Aloha! It's time for some more math on demand with Stoltz. So, today we are looking at this idea of congruence and triangle congruence in particular. If two shapes are congruent, it means they are exactly the same. Mathematically speaking, when we talk about congruence or we use the term congruence, what that means is, um, oops. That just dropped out on me. That's more fun. Good times. 1 second. Let's see if we can't get it back. Otherwise, I'm going to have to restart, and that wouldn't be any fun. All right, so we're back again. What it means if two shapes are congruent is congruent means identical. So if two shapes are absolutely identical, all the sides are the same length, all the angles between the sides are the same, then they are congruent. We use the symbol, it's an equal sign with the tilde on top to represent those. So what we're going to focus on today is triangles and how we know that they are congruent. So if we look at this diagram, we can see that triangle ABC, which is this one here, ABC, is the exact same, or it's congruent with the other one, because all of the corresponding sides, AB is congruent with the side EF, and BC is congruent with the side FG. And I think you get the idea. All of those sides are exactly the same because all the sides are the same and all the angles are the same, because you'll notice that angle ABC is the exact same as angle EFG. That's one way of writing angles, by the way. Another way we could have done this would be, I could write down that ACB, when I talk about that, that's this one here is ACB, is congruent with EGF. And again, the little hat on the middle means that that's the angle we're talking about. It's always the letter in the middle that talks about which one we're talking about. And we can do that with the rest of these if we wanted to. Just to save some time, I'm not going to do that. I hope that makes a little bit of sense. Where we're going to go on to is the things that we need to know in order to prove a triangle is congruent. Somewhere before, I'm sure I've mentioned that triangles are rigid polygons. What that means is there are very specific traits and things about triangles that we can use to prove that they are congruent. First and foremost is this side postulate. That's what SSS means, is side, side, side. And what that means is if each of the corresponding sides of a triangle are congruent, then the triangle has to be congruent. It means that we're locked in. If all the sides are the same, all the angles are the same, we're done. It's congruent. So anytime we see that all three sides are the same length, because that's what it means for a side to be congruent, is it has to be the same length. They are congruent. So we know that this one's congruent. We can see that 4.5 and 4.5 match, and we can also see that 4 and 4 are the same. So those two triangles, and I'm just going to label this A and B, I could say that triangle A is definitely congruent with triangle B. And that's one of the things that we're going to be working on over the next few days is practicing this idea of how can we prove that two triangles are congruent. So that's the first way we can do it. The second way we can do it is called the SAS postulate, or the side angle side. What that means is if I have a side and another side that are congruent, and the angle in between them are congruent, then the two must be congruent themselves. This is something you definitely want to write down. It's something that's really important, but let's just go through and check this one here. So I've got a side that's 5.2. I have another side over here that's 5.2. Those two are congruent. I'm good. Next up, I have a side that is 3.8 and another side on the other triangle that is also 3.8. Again, I'm good. Last but not least, I need to check one more thing. This thing did something strange to me again, because that's fun. And let's get back to my thing. And the last thing we have to check is our angles. And our angle, I think we can see they're both 35 and 35. So because I know that side AC is congruent with side DE, I should actually write that the opposite way. It's ED, not DE. And the side AB is congruent with the side EF. And then finally, because angle FED is congruent with angle BAC, because of those three things, I have side angle side, and that means that these two have got to be congruent. Again, a really, really helpful postulate. It helps us figure out all sorts of things when it comes to just proving that two triangles are in fact congruent. We love that one. Up next, ASA. Gonna let you guess for a second. Mahalo, that's right. It is angle side angle. Angle side angle. And notice it must be in that order. You don't have a choice. It has to be an angle, a side, and the other angle. The angles have to be sandwiching that side in order for this postulate to work. And again, by having this work out, we end up with angle side angle. That makes them congruent. So I can check this. You can see there, I've got a 70, a 6 centimeter line, and a 45. I've got a 70, a 6 centimeter line, and the other enclosing, the one that's sandwiching that side is also 45. These two triangles have got to be congruent. We got one more, well, two more really. And this other one we call the angle side. So if we're in that order, and I'm going to draw these in, angle, and then another angle. And then if we knew that these two other sides were congruent, we have that angle side. Notice, it's not going to be sandwiched between the two angles. That's what makes this different from the other one, is we have an angle, and then that side, and that will mean that these two triangles have got to be the exact same triangles, okay? And finally, we've got hypotenuse leg. Sometimes this is abbreviated as RHS, which means right triangle, hypotenuse, and side. I've always called it hypotenuse leg, RHS. There's a couple other variants. So if you call it HL or RHS, I'm more than happy. But what this means, or what this represents, is this idea: if I have two right triangles, and the right triangles have their hypotenuse are the same, and one other side is the same, then those two triangles have to be the same. Now, the reason why that exists and the reason for this to happen is Pythagoras. If I tell you that this is 3 and this is 5 and this is 3 and this is 5, the other side, because of Pythagoras, has got to be 4. There's no other option, which means, because of side, 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 they're the exact same triangle. Those angles have to be the same, all of that, okay? So that's a really nice thing. I have for you here something that maybe you want to take a screenshot of while you're doing this, or maybe you just want to sketch this. But this is a really good reminder of those rules. Okay. Now, obviously, there's permutations, there's things that we can do with this, and that's what you're going to be doing later on as you work through some of the content on this, where we can spice it up with some algebra. Anyway, I hope this is helpful. Aloha, y'all. Now I need to find the way to turn it off and stop.